A very important process in Liberia, fertilization. This is one of the key tropical soil forming processes we need to understand. Under prolonged warm and humid conditions, minerals are intensely weathered, silica is removed, bases are leached downward and out from the profile. What remains behind are iron and aluminium oxides, which gradually become more and more dominant. That is why these soils are often very red, yellow, deeply weathered, and chemically very poor. In the field, we usually recognize fertilization by strong red or yellow colors, a very deep weathering profile, fairly uniform clay distribution, very low nutrient holding capacity, and highly weathered mineralogy. So in very simple terms, fertilization is the long-term tropical process that creates deep, iron oxide-rich, highly weathered soils. Plintite formation, extremely important in Liberia. It's a typical tropical soil forming process linked to the fluctuating wet and dry conditions. When the soil becomes saturated with water, iron becomes mobilized. When the soil dries out again, this iron segregates and concentrates. Over many cycles of these wet and dry conditions, so over many cycles, these iron-rich concentrations can first form soft plintite, but later they harden irreversibly, especially when exposed to air, when they dry out. In the field, we recognize this process by reddish mottles, iron nodules, partially hardened zones, or even iron cemented layers, petroplintite, for example. This process is extremely important because plintite can strongly restrict rooting, change the drainage, and influence the land use. In simple terms, plintite formation is the repeated concentration and hardening of iron under fluctuating water conditions. Another important soil forming process, redox processes and clayization. This is a very important process because it directly reflects water conditions in the soil. In well-drained soils, oxygen is always present, but in poorly drained environments, such as valley bottoms or depressions, water fills the soil pores and limits oxygen supply. When oxygen is limited, iron behaves differently. It is reduced under saturated conditions and becomes mobile. When the soil dries again and oxygen returns, this iron is reoxidized and precipitates. This repeated iron reduction and iron oxidation creates very characteristic features in the soil. We see gray or bluish or even greenish colors from where iron has been removed, and reddish mottles where iron has accumulated. So these patterns are not random. They are direct evidences of fluctuating water conditions. In Liberia, these processes are very common in lowland environments where water accumulates or the groundwater is shallow. So when we see gray colors and reddish mottling in the field, you are not just seeing colors. You are seeing the history of water movement and oxygen conditions in that soil. Another important, peat formation. It's important because it shows a process that is possible in Liberia, but only in very specific environments. Peat formation happens when the soil remains saturated with water for long periods. Under those conditions, oxygen is limited, decomposition slows down, and plant residues accumulate faster than they decompose. Over time, this leads to thick organic layers and peaty materials. In Liberia, this process is not typical of the well-drained uplands, where decomposition is usually rapid and organic matter turnover is high. Instead, peat formation is mainly associated with swamps, wetlands, permanently waterlogged depressions, and some coastal or inland marshy environments. It is also important to distinguish between two kinds of organic surface horizons. If the organic material is saturated for prolonged periods with water, we are dealing with so-called H horizons. If organic residues accumulate at the surface but remain aerated, then we are dealing with so-called O horizons. Another dominant soil forming process in Liberia, which is also a typical tropical soil forming process. This is a so-called nitidization. As I mentioned, this is also a typical soil forming process that creates a very characteristic clay-rich subsoil. The important point is that this subsoil is not only clayey, but also very well structured and stable. In the field, we recognize it by strong structure, shiny soil aggregate surfaces, very high stability, and gradual clay increase. This reflects long-term stable soil development under humid tropical conditions. Now we jump to soil forming processes that may occur locally in Liberia. The previous ones can be considered as dominant or at least very important ones. But here we focus on that can be present but may occur locally. And the first one is salinization. Salinization is not one of the dominant typical humid tropical soil forming process. Because rainfall is high and leaching is strong, salts are usually removed from the soil rather than accumulated. So, in most inland settings, far from the sea, we would not expect salinity to be a major soil forming feature. However, in coastal lowlands, estuaries, tidal environments, and other poorly drained sites influenced by seawater or brackish water, localized salinization may occur. In those settings, we may observe surface salt accumulation, helophytic vegetation, or other signs of salinity. So the correct interpretation is that salinization is possible in Liberia, but mainly as a local coastal process rather than a widespread country scale one.